back to base 6, because the question has to convert back to base 6. So in doing so, let's convert this to base 10. We have 2, 4, 3, 4, base 6. Following the trend, 0, 1, 2, 3. So I have the first number 2 multiplied by the base, the number on it, raised to power number on it, 1, plus the second number 4 times the base, raised to power the number on it, 2, plus 3 times 6, raised to power the number on it, 1, plus 4 times 6 raised to power the number on it, 0. Then we have 6 raised to power 3. That will definitely give us 216. So we have 2 times 216 plus 4 times 2 raised to power 6 raised to power 2. That is 36. Plus 3 times 6 raised to power 1, 6. Plus 4 times 6 raised to power 0, 1. So here we have 2 times 216. We have 432. Plus 3 times 4 times 36. 36 times 4. That is 144. Plus 3 times 6, 18. Plus 4 times 1, 4. Then we had this up. We have 432 plus 144 plus 18 plus 4. Then we have 598 now in base 10. We have converted that to base 10. We still move on and convert also this to base 10. 42 base 6, 0, 1. First one, 4 times the base, raised to power the number on it, 1, plus 2 times 6, raised to power the number on it, 0. Then here we're going to have 6 raised to power 1 times this, that's 24, plus 6 raised to power 0, 1 times this, 2. Then I have 26 base 10. Now I have both in base 10, so I now want to divide 598 divided by 26. 598 divided by 26 will definitely give me 23. So that will give me 23 in base 10. Am I going to leave the answer this way? No, because the question asked me to divide and both numbers are in base 6. So by the time I have, for convenience, I have succeeded in converting to base 10 and I did my division. Now I have it in base 10, so I need to convert back to base 6. And if I want to convert this to base 6, I just need to divide this 23 by 6. 6 in 23, I will have 18. That is 3. Remainder 5. 6 in this, 0. Remainder 3. Then what do I do next? I count upwards. So I have 35 base 6. So I go to my option and look at the answer that matches what I have. 35 base 6. So it is option B that I will click on. Then the last for this part, find x if x base 4 raised to power 2 equals to 100 base 2. So in this also we have x base 4, that means it's in base 4 squared, equals to 100 base 2. This is also a UTME question. It's also a UTME question. So in this situation, we have this in base 4. We also have this in base 2. What do we need to do? Convert to base 10 to standardize both the left hand side and the right hand side. To standardize both the left hand side and the right hand side. And by so doing, I will have this to base 10. So I have, that will be x raised to power 2 times 4 raised to power 0. That is to convert this to base 10. Then here too, I convert to base 10. 0, 1, 2, 3, 4, 5. So I have 1 times 2, which is the base, raised to power, the number on it, 5, plus 0 times 2 raised to power the number on it 4 plus 0 times 2 raised to power the number on it 3 plus 1 times 2 raised to power the number on it 2 plus 0 times 2 raised to power the number on it 1 plus 0 times 2 raised to power the number on it 0. Now I have this one will now be x squared. This one 2 raised to power 5, that is 32. 32 times 1, 32 plus 2 raised to power 4, 16. 16 times 0, 0 plus 2 raised to power 3, 8. 8 times 0, 0 plus 2 raised to power 2, 4. 4 times 1, 4 plus 2 raised to power 1, 2 times 0, 0 plus 2 raised to power 0, 1. 1 times 0, 0. Then I add this up. By adding this up, I'll have 32 plus 4. That is 36. So x squared equals to 36. Then my x will then be square root of 36. X equals to 6. You will not stop here because this x is x to base 4 and is equals to 6. Meanwhile, I converted this 100 base 2 to 36. So this one is in base 10, while x is in base 4. So to now calculate our x, we need to take this to base 4. So it will now be 6 divided by 4. 4 in 6, 1, remainder 2. 4 in 1, 0, remainder 1. Then I count it upwards. Then I have 1, 2, base 4. So I now have x raised to power x base 4 equals to 12 base 4. Then x can cancel, 4 can cancel 4. Then my x equals to 12. So to base 4, x equals 12. Now, another topic under discussion is indices. Indices is of significance, the indices. And before you can survive here, you must be able to recall all the laws attached to this topic. From our previous knowledge or classes, we've been able to know or to master all the laws, but I just want to do a summary. In law of indices, we have so many laws that bind these indices. Well, the first, we have so many laws, and before we can survive here, we must be able to recall the laws offhand. The first law says that if you are operating based on y, first one is saying that y raised to power a times y raised to power b is the same thing as saying y a plus b. The second one is saying that y raised to power a divided by y raised to power b is the same thing as saying y a raised to power minus b. Then the third law is saying that y raised to power minus a is the same thing as 1 over y raised to power a. The fourth law is stating that y raised to power 1 over a is the same thing as saying square root of y, this way. Then the fifth law is saying that y raised to power b over a is the same thing as root of a y, everything raised to power b. Another one is stating that when you have x raised to power a over y raised to power a can be written as x over y, everything raised to power a. Then we have another one that states that when you have x, y, everything raised to power a can be written as x raised to power a, y raised to power a, etc. These are the basic laws of indices, which we need to recall when necessary in solving the UTME question related to indices. Also, let me quickly talk about the twin brother, which is logarithm. Logarithm also is not different from indices. Now, if you talk about logarithm, on the other hand, logarithm also has laws binding it. The laws of logarithm that we have one. That one, the first one states that if you have log of AB is the same thing as log of A plus log of B. The second one is stating that if you have log of A divided by B is the same thing as saying log of A minus log of B. Then the third law of logarithm is stating that when you have log of A raised to power P, for example, is the same thing as P log A. Then you know that fourth one, log of the same base is equal to 1. Then we also have fifth one stating that log of A B raised